Find the position vector of a point C in AB such that A vector and B vector are the position vectors of point A and B respectively. When AB is extended beyond point B, then AC becomes equals to 3 times AB. Also, there is another point D such that when BA is extended beyond A, then BD will be equals to 2 times BA. Okay, so our goal will be to find out the position vector of a point C in AB. Okay, let's begin. First, we'll try to understand the problem graphically. So here, to begin with, we're going to consider 2 points, point A and point B. So here, we're going to join point A and point B with a straight line. So it's given there, when AB is extended beyond point B, so that means we're going to extend the point B to the right hand side, and it's going to meet at a point, let's call it the point C. Now the point C is chosen in such a manner such that the length of AC is going to be thrice that of AB. So we can say here that B divides AC in the ratio 1:2. Next we have another point D such that when BA is extended beyond point A, then BD will be equals to 2 times BA. Now that means we're going to extend the point A to the left hand side, which meets at the point D. Now the point D is chosen in such a way such that the length BD is going to be equals to 2 times the length of BA. So here we can say that A divides BD in the ratio 1:1. Now our goal will be to find out the position vector of the point C. So what we'll do, we'll consider an arbitrary point O, which is going to be the origin of some coordinate system. Then we can define the position vector of each of the 4 points A, B, C and D. All we have to do is join point O and point A, point O and point B. That means join with the origin with each of the following points with the help of a directed line segment, and that's going to give us the position vector of each of the 4 points. Now in the problem, it's given here that the position vector of point A is A vector and position vector of point B is denoted by B vector. That means OA vector, that's equals to A vector, and OB vector equals to B vector. Fine. So we'll try to find out the position vector of point C. So let us suppose that the position vector of point D, which is OD, that's given by the vector D, and OC vector is given by the vector C. Fine. Now, since we have already established that point B divides AC in the ratio 1:2 internally, so here we can find out the position vector of OB. That means we can define the position vector of B using the internal section formula. All we have to do is take 1 and multiply it with the position vector of point C. So we have 1 times C vector added to. Next, we'll take this value 2 and multiply it with the position vector of point A to get 2A vector, whole divided by 1 plus 2. Now, OB vector, that's simply B vector, where B vector equals to C vector plus 2A vector divided by 3. So, cross multiplying gives us 3B vector equals to C vector plus 2A vector. Now, we can rearrange the terms to find out C vector. So C vector will be 3B vector minus 2A vector. And what is C vector? That's nothing but OC vector. The OC vector is given by 3B vector minus 2A vector, and this is going to be the position vector of the point C.